Gentles and ladymen, I'm Spiro, and I'm not a wizard. Today is part 3 of our Learn Commodore 64 BASIC series. I do want to quickly go back over, in the last lesson we learned about the limitations of variable names, among other things. Only the first two characters of a variable name are significant. So you could have a variable, my goodness, called variable. Can I spell today? It's early in the morning. I've only had one coffee, so please excuse me. I'm also expecting technical difficulties because that's kind of par for the course. So let's go variable equals 1, and as we can see, we can print VA because only the first two characters are significant, and we get the value that we pumped in. We can also print vary because I wasn't supposed to print. Told you, coffee. Let's go print vary. It's going to ignore any from character 3 onwards. There we go. So because of that, we cannot use any existing reserved words or basic keywords for our variable names. Now, I went over some of those in the last video, but I missed a few. So I mentioned fn for function, I mentioned the bitwise OR, and I mentioned the time variables ti and ti string. But I forgot for some reason about if, to, and on, and status. We'll get to these. But this is a variable, so the variable name is st, whereas these are commands, and they are only 2 characters. So, in short, if you see an existing basic variable or keyword, you can't use that name as your own variable in your programs. So let's clear the screen. Shift home. I want to continue what I didn't have time to mention in the last video, which is converting strings and numbers back and forth. So if we just do a quick recap, we can store a number in a string, and it is stored because it has the $, or what I will be referring to as, when I say string, I'm talking about that $. So a string is a string that contains a number, but it's not treated as a number by BASIC. If we set a variable of a and we don't specify that it's a string, it'll be a number. So we can put 45. Okay, so we can now print each of those separately because they're different variables. If you recall, a and a string are treated as different variables. So we can now print, and the shortcut for print is the question mark. We can print a and we'll get 45, and we can print a string and we'll get 232. And again, we can identify that this is a number because there's a space there, and there's no spaces printed before a string. And the numbers get the space put in there as a placeholder for a sign. So if we put a equals -45 and then we print a, you'll see it doesn't have that space, it's now replaced it with the sign. Okay, so let's make a positive number for these purposes. What we might want to do in our code is say, well, let's add those two numbers together. We know they're numbers even though one is a string, treated as a string by BASIC. But we know they're numbers and we'd like to add the two together. We can't make a new variable adding them together, a string, because they're two different types. One's a number, one's a string. We're assigning them to a number. So BASIC is going to barf. It's a type mismatch. So it is basically saying these two types of variables are in conflict. I can't add those two together. I can't give you a number out of a string. So what we can do instead is we can convert that string into a number. And we do that with the val keyword, which produces the value of a string. So we can actually go B, and we can do this without affecting the original string variable. So we can basically do this conversion on the fly and say, for the purposes of this equation, a plus a string, for the purposes of this calculation, just convert it a string into a number, but we'll leave a string as is. So a string will still be a string. So we can convert it with val. So let's say we want the value of a string. So we're saying we want the number a plus the value of a string, add those two together and put them into B. And that has worked. So if we now print B, we should have the sum of 232 and 45. And without me getting a calculator, that looks about right. So we still have a string intact, and it is still a string, as evidenced by no space at the beginning. So value doesn't convert a variable, it just well, I shouldn't say it doesn't convert a variable permanently, it just converts it on the fly. Okay, so the other thing we can do is we can try and assign those two to a string. Let's see if that works. That also failed. So for the same reasons, we're creating a string and we're trying to add two different types of variables. So the opposite of or the inverse of the value command is the string command. str string. So we can say b string equals the string of a, because that's a number, so we're converting a number to a string, plus a string. Now it might look like a mathematical equation. We're not adding numbers, we're saying the string, when we're doing string manipulation, we're concatenating two strings. Okay, so we should now have, if we print b string, 45 232. Now you'll notice that that string conversion of the number kept that space in front of the 45. So that's a quirk and something to be aware of. The ways around that really are to either cycle through the string once you've produced it and remove those, or to use left string and right string. So let's show you because for the purposes of this, we know A is 2 digits. Actually, let me cover another command here called len. So len will tell you the length of a variable. So if we print len A, we can see it's actually only working on strings. So if we say len, let's go A string 3. So our A string is 3 characters. So that's telling us that it's 3. Now you'll notice that it has also returned it as a number, that len command. So for the purposes of printing that out, for the purposes of calculating though, we can print, let me see how I'm going to do this. We know the length of a variable is effectively 3 bytes, and we want the last 2. Let's print the length of string of a. Okay, so we couldn't get the length of the a variable as a number, but we can get the length of it as a string. We also get 3. So we can use that and say, okay, well, let's chop off that first character, or rather let's just get the last 2 characters, and we can use that by using the right string command here. So what this does, maybe I should click on these, is this will allow you to get the to specify the number of characters from the right side of the string, however many you choose. So right string, we're going to pass the string and a number, an integer. So we will say we want this many characters from the right side of that string. So we can print right string, and remember we have to convert that number to a string because this is a string function of a. So we've now said we've got right string, open parenthesis, and our variable that we're passing, or the string that we're passing, is the converted converted to a string. And now we want the last, so we want the right hand most 2 characters. So we're going to grab those. So it would normally, the string would normally be space 4-5, but we just want the last 2 characters, which are 4-5. And you'll see that prints it without that space at the front. If left string is the opposite of that, so if we, let's just make a S string equals 1, 2, 3, 4, and we want to say print the first 2 characters on the left, we can do the same kind of thing. We can print left string. Now, but we don't have to do a conversion this time because we're already working with a string. So if we want the left hand most two characters, this will return 1, 2. Okay, so I hope that is a little bit clearer than mud. There is another type of conversion, which is character string. Now this one takes a little bit more background information. This is actually working with not the numerical values so much, but how they're interpreted as screen codes on the screen. So for a bit of background on this, a great file to have a look at and to print out is on slarkme/C64. He's got a PDF file. Let's go Commodore 64 PETSCII and screen display characters chart. So what that is, so PETSCII, if you know what ASCII is, that is the screen characters on your computer. The Commodore 64 version of ASCII is called PETSCII, and that came from the Commodore PET, which was the original predecessor of the Commodore 64. So the character sets are different to our normal, on modern computers, ASCII characters. So if we click on that, there's a PDF we can download. If you grab the one that says -black, because that's the one I grabbed, it's a bit easier to read. It gives you a list. Now this might look daunting at first, but you'll see that there's a whole lot of graphic characters. Now these are PETSCII characters. You won't see those in your standard Windows or Mac or Linux computer. These were historical Commodore stuff, and in fact you won't see them on any other 8-bit computer of the day. Atari had ASCII, so they had their Atari version of ASCII, and it was just that there are standard characters, the letters and the numbers, and your hashes and exclamation marks and so on. But then they added graphic characters as a way of customizing and making things look pretty on their computers. So this here, just to give you a quick rundown of it, we've got a few. So there's actually effectively two columns here. We've got this side and this side. So we've got decimal, hex, screen code, control code description, and the quote mode character, and then those are repeated here: des, hex, screen code, etc. So there's effectively two columns of information here. This is the decimal representation of a character, and this is the hexadecimal representation of a character, or rather of the screen code. So and this is what it will look like when it's printed to the screen. Now there's uppercase and lowercase. You'll notice that your Commodore 64 only displays uppercase. There are two character sets. We can actually press Shift and Commodore, and that takes us into character set 2. Shift Commodore again, character set 1. So when you see two columns here in the screen code, the first one is character set 1, which is the default that you look at, and the second column is what they will look like in character set 2. And so we go down here, extended characters. You've got ones that look different depending on what character set you're in. So going back to the character string command, that works on these numbers and these characters. So what it's going to do is it's going to convert a number to an ASCII character, well actually a PETSCII character. So if you say you want the character for the number 2, you would pass the number 50 to character string. So let's just give that a quick try. If we want to print out the number 2, so we want Commodore BASIC to return the screen code for the digit 2, we would say please print the character of 50. So please print the character represented by the decimal code 50, and that gives us a 2. If we want to print a colon, if we look down here, our colon is decimal 58. So if we change that to 58, we'll get a colon. So that is another form of conversion. I won't go into when it may or may not be useful, but it's actually a good way of printing characters that there are no immediate keys for, or actually I will give you a good one, because some of these are control characters. They're not displayable. For some reason this has got screen codes ABC down here, but these lower numbers are actually not where the characters are. The letters are here, the PETSCII code. So this is what will get printed when you're typing ABCD. So these are actually control codes. You'll see here, if you print the character string 5, it'll change the character color to white. Now my character color is, let's change that. So if I go print character string 5, this might be a bit hard for you to read, it has changed our character color to white now. You see? Another interesting one is down here, the clear screen. So if you remember the shift clear, the home key, if we press home, will go to the top left of the home location of the screen. If we press shift home, it will clear the screen. But the character code for that is actually decimal 147. So we could press shift home, or we could print character string 147, and that will do the exact same thing. Of course it doesn't look as pretty because you've entered a command and Commodore BASIC has now returned and said, great, the command has been done, I'm now ready. Whereas if we had just pressed shift home, it would be completely clear. But we can actually use that in the character string version in our programs as a quick way of clearing the screen. And I use that all the time. I'll get into another way of doing that in a future video. For these purposes, we're doing conversions. So I think that is going to cover our episode of conversion therapy. The So a quick refresher, val converts a string to a number, string converts a number to a string, character string, how do we put that, converts a number to a screen code. Yeah, and a couple of other things we learned are left string, oh I can't do that, left string gets the leftmost characters of a string, and right string gets the rightmost characters of a string. And we also learned about len, which gets length of a string. So it's useful to know if you want to do any of these but you're trying to do it on a different type of variable. If you're trying to do a string calculation or manipulation on a number, convert it to a string first with strstring, and then you can use things like left string, right string and len on it. And if you want to treat a number like a string like a number, you would use the val command. So I hope that was useful. Let me know what I missed in this episode, because I'm sure I've missed something. I always do. And thanks for watching. Thanks for your support. And please leave any other comments and feedback and your thoughts in the comments below. And I'll see you in the next video.